Hi, welcome to Demystifying Math. In this lesson we're going to be discussing arc length. We want to find the distance between points E and F going along the curve of the function f of x equals x to the 3/2. What we're going to do to start off is find the length of the secant line between points E and F so we can get a pretty close estimate for what the arc length will be. We can find the length of the secant line by using the distance formula. We're going to plug in the ordered pairs starting at x equals 1 and going to x equals 4. We got the length of the secant line as about 7.616 or 7.62. Now, if we wanted to get a better estimate for the arc length, we would take that arc and break it up into even more segments. So let's go ahead and do that. Here we have it broken up into 3 segments. And we found the length of each segment. From E to G about 2.08, from G to H approximately 2.57, and from H to F about 2.98. Then we added together the lengths of each of those segments. We got 7.63, which is not very far off from what we got by using just one secant line, as 7.62. Okay, so as we increase the number of segments, the lengths of the segments, the sum of the lengths of the segments, would approach the total length of the arc. So what we're going to do is use the distance formula to help us develop a formula for arc length. We're going to let the difference between our x values be called delta x, and the difference between our y values be called delta y. We're going to substitute into our distance formula, where we had x2 minus x1, we put delta x, and y2 minus y1, we put delta y. Now we have the sum of all those little segments that we're going to find. So we have the summation there. And we're just going to do a little bit of algebra on this. We're going to multiply the delta y squared term by delta x squared over itself. So in other words, we're just multiplying that term by 1. Then we're just going to change it about a little bit and pull out the delta x squared, or factor it out. Well, what you should notice is that delta x squared is square rooted, so we're going to take it out from under the radical. And then we're going to take the limit as n goes to infinity. So we want to take the limit of the sum, which is going to give us the exact arc length. Now what you should notice is that we have delta y over delta x, and delta y over delta x is slope. And we can find the slope of a function by taking the first derivative. So that's f prime, and we're calling it c. And c just represents at any point. So now we have the limit as n goes to infinity of the sum from j equals 1 to n of the square root of 1 plus the function's derivative squared. And then outside the radical we have the delta x. So now all that is left to do is to rewrite this as an integral. So we have the sum from a to b, the 2 endpoints of the arc length that we're looking for, and the square root of 1 plus f prime of x squared, and the delta x just became dx. As long as your function is continuous on the integral from a to b, this will be a good formula for us to find the arc length. Okay, so let's go back to our example of x to the 3/2. What we want to do is first find the derivative of the function. So that's going to give us 3/2 x to the 1/2. And then we're going to square that, so we get 9/4 x. Then plugging into our arc length formula, we have 1 plus 9/4 x. And then we're going to simplify it a little bit. So I multiplied the 1 by 4 over 4. To find a common denominator and added them together. Now what you should notice is that 4 is a perfect square, so we can take it out from under the square root symbol, and we can also take it outside of the integral. Now to solve this integration we need to use some u substitution, so we're going to let u equal 4 plus 9x, which gives us du is 9 dx, or 1/9 du is equal to dx. We also want to replace our x values on the endpoints of integration with u values. So plugging into u, our value of 1 became 13 and our value of 4 became 40. So that gives us the integral from 1/2 from 13 to 40 of 1/9 times the square root of u du. Then we can integrate that and we get 2/3 u to the 3/2 times 1/18. And then we're just going to plug in our endpoints of integration and we get 7.6337. Very close to what we got by just using 3 secant lines along that arc length. So you can see how easily the arc length formula will work for us. Thank you for tuning in to Demystifying Math. Let me know if you need anything else. Have a good day.